Introduction to Wood Preservation. Purpose and Learning Objectives. Purpose: preservative-treated wood can help ensure a project's durability. This course reviews the manufacturing process of pressure-treated wood. Learning Objectives. At the end of this program, participants will be able to discuss how preservative-treated wood products are manufactured, the steps taken to ensure proper quality control, and the types of preservatives used today. Specify preserved wood products using the AWPA Use Category System. Outline the best management practices, BMPs, regarding the use of preserved wood. Understand specifications for railroads and utilities. Contents: Introduction to preserved wood. How wood is preservative-treated. Today's preservatives. Specifying using the AWPA Use Category System. Preserved wood for railroad ties and utility poles. Best management practices for aquatic uses. Environmental benefits of preserved wood. Summary and resources. Introduction to preserved wood. Sustainability through preserving. Wood is the original sustainable building material. Created seeds, soil, and water. A tree grows as it feeds off nutrients in the soil and sunlight, while taking CO2 from the atmosphere and converting it into carbon and oxygen. After a tree grows for 30 to 80 years, they're large enough to be harvested and converted into lumber, plywood, and poles. New trees are planted to ensure forests and wood products are available in the future. The service life of wood products is expanded from a few years to decades through preservative treating. By the time a preserved wood product has served its life, a new tree will be grown to become the resource for a replacement product. Planning for longevity. There are a variety of organisms that seek to break down wood fiber. These organisms seek to break down the wood fiber, reducing the structural soundness and serviceability of the wood. This stave church was constructed from wood more than 800 years ago and remains in service today. Unique design elements help protect the wood. Maintaining the durability of exposed wood requires protection from organisms such as decay fungi, rot, termites, wood-boring beetles, carpenter ants, other wood-destroying insects. Wood decay, fungi, and rot. It is estimated that there are more than 100,000 species of fungi that exist in the world, comprising 25% of the planet's biomass. Spores from fungi are ever present in our world, making it difficult to protect wood that is exposed. For decay fungi to deteriorate wood, it needs 4 basic things: food, wood, suitable temperatures, moisture, oxygen. Since it is impossible to control temperature, moisture, and oxygen for wood used outdoors, the most effective option is to change the food so it is less attractive. Wood decay, fungi, and rot. One danger to wood from decaying fungi is that it may be difficult to detect, particularly if the wood is coated with paint or heavy stains after the decay has started. A raised deck with a painted underside may appear to be sound on the surface. However, infrared scans show that parts of the wood have decayed prior to the application of the paint. This decay could significantly impact the structural capabilities of the wood. Wood products placed in the ground or just above the ground have higher risks for decay fungi. Moisture and organic material in the soil or in ground-level vegetation provide a quick route for decay fungi to impact the wood. Termites and other wood-destroying insects. Other threats to wood include a variety of wood-destroying insects. These are found in forests and other areas and help break down dead and dying trees and vegetation into organic material. These insects search for dead wood to eat, including wood that has been converted into a wood product. Insects such as termites, ants, and wood-boring beetles thrive in warm, moist conditions. Each year, these wood-destroying insects cause damage to wood products totaling more than $5 billion in the United States. Protecting wood from decay and insects. The best way to protect exposed wood from decay, fungi, and insects is to change the wood so it's no longer desirable as a food source to such organisms. Using wood's unique characteristics, a protective shell of preservatives can be infused into the wood. The preservatives are not just on the surface, they're infused deep into the wood to provide long-lasting protection. The process of pressure treating creates a barrier in the wood to discourage deterioration. Once the wood has been treated, it can be used the same as an untreated wood product in construction. Today's preservatives. Wood pressure treating process. Efforts to protect wood from deterioration are as old as civilization, with records about wood preservation dating back to ancient Greece and Rome. Commercial pressure treating began in the mid-1800s, focusing on extending the service life of rail ties, utility poles, bridge timbers, and marine piles. The first standards for pressure treating wood were published in 1904. Over the next century, the treating process and preservatives evolved into an industry producing billions of board feet of preservative-treated lumber, timbers, plywood, pilings, and utility poles. Preparing wood for treatment. The manufacturing of preserved wood products is a simple, straightforward process. Typical species used in treating are Douglas fir and hem fir in the western USA and southern yellow pine in the eastern part of the USA. Hardwoods are used for railroad ties and bridge ties. Lumber, timbers, and plywood are purchased from sawmills or plywood plants. To prepare for treatment, the lumber and timbers may be resorted or trimmed at the treating plant. Poles are typically sourced from forest companies or timberland owners. Treating process. Loading the retort. The wood is moved into a pressure cylinder called a retort. The retorts used in treating today can be from 60 feet to 140 feet in length. Once the wood is inside, the retort is sealed and a vacuum applied to remove the air. Liquid preservatives are pumped into the retort, filling it completely. Pressure is applied to move the preservative into the wood cells. The amount of time the wood remains in the retort depends on the species, size, product, preservative used, and level of protection desired. Treating process. Final stage. After the treating cycle has ended, the preservative is drained from the retort and a vacuum is applied to return the excess solution to storage tanks for future use. The preserved wood is moved onto a sealed drip pad to reclaim any residual preservative on the wood. Representative core samples are taken and analyzed to ensure that quality and durability standards are met. Third-party inspection agencies also take core samples during regular visits to confirm the plant's quality control practices. The finished preserved wood products are moved to the plant's storage area for shipping, where the unit of wood may be covered with a top wrap. Today's preservatives. Wood preservatives overview. There are a variety of wood preservatives used to provide the durability and performance of any application. All preservatives used today have undergone rigorous reviews and are registered by the U.S. Environmental Protection Agency, EPA, for use in pressure treating wood products. The effectiveness of these preservatives is well documented, and their use in treating is guided by national consensus standards. In the United States, the American Wood Protection Association, AWPA, sets those standards. Safety of wood preservatives. The active ingredients in wood preservatives are also used in a variety of consumer products found in everyday life. Copper is the main ingredient in waterborne and best oil-borne preservatives found in most residential and industrial preserved wood products. Copper has been used for centuries as an antimicrobial. Other ingredients include biocides and fungicides to protect the wood. These include quaternary compounds that are found in disinfectants and household cleaning products, as well as hair and body products. Wood Preservative Standards. The American Wood Protection Association, AWPA, is a non-profit organization which promulgates voluntary standards for preservative-treated wood products. These standards are published in the AWPA Book of Standards, which establishes the retention, or how much preservative is needed in the wood, and penetration requirements for each preservative based on its intended use. AWPA standards are referenced in building codes and the use categories defined in the standards to provide guidance to specify the right products to meet service requirements for the conditions where the preserved wood will be used. Types of wood preservatives. There are two types of wood preservatives available, based on the carrier used to infuse preservatives into the wood. Waterborne preservatives use water to carry them into the wood during pressure treating. These preservatives are found in wood products typically used in residential and some commercial applications, such as Cellutreat for sill plates and home framing in Hawaii, and QNAP-Copper Naphthenate for fence posts. Oil-type preservatives are dissolved in petroleum products, such as mineral oil, to infuse them into the wood. These preservatives are suited for demanding exposures, where maximum protection is required, most often for commercial or industrial applications. Examples would include QNAP-Copper Naphthenate treated railroad ties, utility poles, and bridges. Cellutreat, DOT, Inorganic Boron. Cellutreat is an inorganic boron used to prevent termites and fungal decay. It may also be referred to as DOT. Sodium borate is water-soluble and is only used in interior applications, such as sill plates, or where it is continually protected from water. It shares similar ingredients to consumer products such as eye drops. Species: Douglas fir, hemfir, southern yellow pine. Uses: interior applications, where its application is continually protected from liquid water. Availability: home centers, lumber yards, distributors. Boracare is a DOT liquid solution with glycols and used for termite protection. Oil-type preservatives. When maximum protection is required, oil-type preservatives are the oldest and most popular in commercial and industrial applications. They are used in demanding exposures, such as ground contact or immersed in water, where risks for deterioration are greatest. There are 4 basic oil-type preservatives used today: QNAP, copper naphthenate; creosote; pentachlorophenol; IPBC, iodoprophenyl butyl carbamate. Oil-type preservatives are commonly used for utility poles, guardrail posts, bridge timbers, retaining walls, rail ties, pilings, and maritime facilities. QNAP, copper naphthenate. Copper naphthenate is an industrial-strength wood preservative and is classified as a general-use preservative by the EPA. It is commonly used to field-treat cuts and holes made in preserved wood during construction. QNAP-Copper Naphthenate is used in treating utility poles, railroad cross ties, bridge timbers, fence products, and laminated wood beams. It is also standardized by ARIMA for railroad cross ties and bridge timbers, and by AASHTO for highway components. Species: Douglas fir, hemfir, western red cedar, southern yellow pine. Uses: above ground, ground contact, freshwater contact, field treatment. Availability: order direct from manufacturers. Field treatments with QNAP available at retail locations. Specifying using the AWPA Use Category System. AWPA Use Categories. To assist in specifying the proper preserved wood product, the American Wood Protection Association, AWPA, developed the Use Category System, UCS. Its purpose is to provide a simple way of selecting the proper preserved wood product directly related to the appropriate AWPA standard. Appearing in the annual AWPA Book of Standards, use categories are based on the potential deterioration hazard for its intended end use. These categories define the level of preservatives needed for proper protection. The value of the system is that all wood uses can be placed into one of 5 use categories that clearly describe the exposure conditions where the wood may be used in service. Use categories are further segregated into subcategories for defined degrees of biodeterioration hazard and expected service life. AWPA Use Categories. The advantage of use categories is simplicity. Smaller use category numbers reflect a lesser amount of protection is required against decay or insect attack. Likewise, higher use category numbers indicate a greater degree of protection. The use categories and respective subcategories for preserved wood typically used in construction are UC1, interior dry, UC2, interior damp, UC3A, above ground protected, UC3B, above ground exposed, UC4A, ground contact general use, UC4B, ground contact heavy duty, UC5A, B, and C, marine use. UC1, interior dry. Wood labeled as UC1 is used in interior construction not in contact with the ground or foundation, for protection against insects only. UC1 products should be continuously protected from weather and interior sources of water such as leaking plumbing, condensate, pools, and spas. Applications: interior furniture, construction furnishings, millwork. UC2, interior damp. Wood labeled as UC2 is used for interior construction that is not in contact with the ground but may be subject to dampness. UC2 products must be continuously protected from the weather, but may be exposed to occasional sources of moisture. Sill plates are the most common UC2 products, as well as framing lumber for termite-prone areas such as Hawaii. Applications: interior beams, timbers, flooring, framing, millwork, sill plates. UC3A, above ground protected. Wood marked as UC3A is used in exterior construction that is coated and not in contact with the ground. UC3A products may be exposed to the full effects of the weather, but are in vertical exterior walls or other types of construction that allows water to quickly drain from the surface. Applications: exterior framing, coated millwork, siding, trim. UC3B, above ground exposed. UC3B marked wood is used in exterior construction that is not in contact with the ground. Wood treated to UC3B does not require an exterior coating but may be finished to achieve a desired aesthetic appearance. A higher use category may be needed for wood products that are physically above ground but exposed to ground contact conditions. This includes sawn components that are difficult to replace and critical to the structure, or that may be exposed to ground contact type hazards due to climate, artificial or natural processes, or construction. Applications: decking, railings, joists and beams for decks and freshwater docks, fence pickets, uncoated millwork. UC4A, ground contact general use. Wood marked as UC4A is used when 1. In contact with the ground, freshwater, or other situations favorable to deterioration. 2. Used above ground but is difficult to maintain, repair, or replace, and is critical to the performance and safety of the entire system construction. Or 3. Used above ground but may end up in ground contact or is subject to hazards comparable to ground contact due to climate, artificial or natural processes, or construction. Applications: fence posts, deck posts, structural lumber, joists and beams for decks and freshwater docks, timbers. UC4B, ground contact, heavy duty. UC4B wood products are used in contact with the ground either in severe environments, such as horticultural sites, in climates with a high potential for deterioration, or in critically important components. Applications: building poles, horticulture posts, utility poles, decking, permanent wood foundations, above tidal piers and docks, areas with high potential for fungal decay. QNAP-Copper Naphthenate treated poles, pilings, and lumber are ideal for freshwater applications, as it is the least leachable preservative available today. Heavy-duty oil-borne wood preservative, QNAP-Copper Naphthenate. QNAP-Copper Naphthenate has a proven longevity greater than creosote or pentachlorophenol, and with safe handling characteristics and superior environmental profile, it is the clear choice for railroads and utilities. Guidance is available to understand use categories and how to use them in specifying preserved wood for typical construction applications and exposures. Go to preservedwood.org/thestory Preservative Use Categories for more detailed information on specifying with AWPA Use Categories. Today's preservatives. Preserved wood quality marks. Most preserved wood products sold in retail locations carry an end label affixed to each piece. While these labels may appear differently based on the manufacturer, all contain the same elements as shown. Section 2304.11 of the International Building Code requires each of these elements be shown on the label. This includes the mark of the Accredited American Lumber Standard Committee (ALSC) inspection agency, which maintains continuing supervision, testing, and inspection of the quality of the preservative-treated wood. The checkmark logo signifies the wood has been produced according to AWPA standards. Fasteners. Do not require. The following preservatives are not corrosive. They do not require any special metal fasteners or fittings. Cellutreat DOT borate, QNAP-Copper Naphthenate, Boracare, Boracare with mold care. Requires fasteners. Care should be taken in the selection of the appropriate fasteners for use with some preserved wood. Ingredients in many preservatives can be corrosive to the steel in fasteners such as nails, nuts, bolts, and washers. Treating for field cuts and drill holes. Preserved wood products are typically cut and drilled during construction. This can expose parts of the wood that were not treated with preservatives, increasing the opportunities for decay fungi and insects to deteriorate the wood. AWPA and building codes require field treating using a treatment containing either copper naphthenate or oxine copper. Use a brush to apply the preservative. Clean the wood surface. Then coat the cut or hole liberally so that the treatment can penetrate into the fiber. A standard paintbrush can be used for most field treating. Handling preserved wood. Some older restricted U.S. preservatives like creosote can cause skin irritation and burns. Advanced preservatives like QNAP-Copper Naphthenate are clean to the touch, which allowed this railroad crew to use a tie stack as a desk on this job site. Follow good personal hygiene after handling preserved wood. Wash hands and any exposed areas thoroughly after handling preserved wood, especially before eating, drinking, or using tobacco products. Avoid inhalation of sawdust from wood products. When sawing the wood, wear a dust mask. Sawing operations should only be performed outdoors. When power sawing, wear goggles to protect eyes from flying particles. Disposing of preserved wood. QNAP-Copper Naphthenate and Cellutreat DOT borate may be burned in boilers that meet non-hazardous secondary materials (NHSM) rules. Do not burn preserved wood in open fires or in stoves, fireplaces, or residential boilers. You can dispose of preserved wood in landfills, as it is not considered hazardous waste. Environmental benefits of preserved wood. Balancing protection and impact on sensitive environments. Protection of water quality and the diversity of life forms in lakes, streams, estuaries, bays, and wetland environments of North America is a goal and responsibility shared by everyone. QNAP-Copper Naphthenate treated poles, pilings, and lumber are ideal for freshwater applications, as it is the least leachable preservative available today. Preservative-treated wood is widely used to construct bridges, piers, docks, boardwalks, decks, and buildings used in or over aquatic and wetland areas. It is critical that structures constructed in these areas are installed in a responsible manner that minimizes any potential for adverse impacts to aquatic and sensitive environments. Preserved wood and the environment. Preserved wood offers many environmental benefits compared to alternative materials. It is the only construction material made from a sustainable, renewable resource. The application of preservatives extends the natural life of the wood from years to decades. Assessing the environmental benefits of any building product requires a more systematic, science-based approach rather than the subjective and sometimes misleading claims that are often promoted. Preserved wood's many benefits are detailed in a series of assessments using internationally recognized life cycle science to provide an objective basis to determine environmental advantages. Life cycle assessments for preserved wood. The preserved wood industry commissioned a number of life cycle assessments, LCAs, comparing preserved wood products to alternative materials in specific applications. LCAs consider the full cradle-to-grave perspective on a product and were conducted according to internationally recognized ISO 14044 standards. The LCA reports were also subject to scientific peer review to confirm the results and have been published in environmental journals. LCA Analysis Results. A quantitative evaluation of the environment impacts of production, use, and disposition indicates preserved wood has significantly fewer impacts compared to alternative materials. A comparison of materials shows preserved wood has less total energy and resource use and lower environmental impacts in areas such as greenhouse gas emissions, smog potential, ecotoxicity, and eutrophication-causing emissions. Summary and resources. Summary. Preserved wood is durable, sustainable, versatile, safe, and environmentally beneficial. Preserved wood products using QNAP-Copper Naphthenate and Cellutreat DOT borate offer these and many other attributes that make it a perfect choice for uses where conditions are demanding. Safety and the environment are critical, and a long service is required. Understanding how to properly specify and use preserved wood products will ensure long-lasting performance. Choose the right product for your project. Wood that lasts. Resources. Use the links below to access detailed technical information as referenced throughout the course.